All right, everybody. We are in weld inspection technology. We're going to be talking about metal joining and the cutting processes. Most of you are very familiar with these at this point. However, there's some things within them that I really want to talk about, some more of the finer details, some little simple things, primarily specific to each individual process as we're going through it. Here it talks a little bit about the benefits of it. Naturally, help spot problems. So for example, if you know it's SMAW or flux core arc welding, then you're going to be susceptible to slag inclusions, right? However, you're not going to be as concerned with penetration as you would be with GMAW short circuit. What's the difference between the four modes of transfer of SMAW, things like that. Leads to better inspection. It also helps that you know how to weld. You don't have to be a welder to be a CWI, but here what we're talking about is welding inspection technology itself, the process of welding, the fusion, the coalescence, and so forth, okay? It does help if you know how to weld or you have welded. My experience is the welders will a lot of times treat you a little bit differently if you can do it yourself as well, all right? However, you also have to understand that not every welder, some of the best welders I know don't understand half of the knowledge that you'll understand by the time you're done with this course. They haven't talked about metallurgy. They're not even concerned with grain structure at this point. They're good welders. They're great welders. They're production welders. They're not necessarily looking at the process of it and so forth. All right. So we're going to talk about welding processes. Number one, some of the advantages of each process, the limitations of each process, the type of equipment is required, filler metals, techniques, and problems. Filler metals specifically is where we've grown rapidly in technology in the last 5 years, particularly, but 10 even more. There is a flux core stainless TIG rod out there. Some of the alloying materials for aluminum, especially, 3D printing alone, we just made a huge advancement in additive manufacturing, so 3D printing. 6061 aluminum, it's where they were adding zirconiated flakes at a certain point and then hardening them with an ultraviolet light, very similar to what you would do with enamel in the tooth. Okay, and that's what creates its coalescence, or gives it the tensile strength or the yield strength required for that to bond effectively in additive manufacturing without bringing it up to a heat, to as high a heat as we do when we're welding it, right? So we're welding it anywhere from melting point 2780 steel to 7,000 degrees, okay, 6,000, whatever. And then we kind of go up and down, which causes some problems, which we'll learn more in the metallurgy portion of it. But 3D printing of it, doing it at that exact point, you don't have to take it up to 3,000 or 4,000 degrees to get it there, to get it to have that tensile strength or that yield strength that's required. It was a game changer. Okay, the grain structure can be controlled, the heat affected zone can be controlled, much different than subtractive manufacturing, which might be one huge piece of aluminum, which costs a ton of money to foundry and pour, and then also turn around and machine it all out, and there's a lot of wasted material in there as well. Okay, so welding is very much like 3D printing. It's additive manufacturing processes versus machining is subtractive manufacturing. Okay, three basic processing groups or processes groups: welding, brazing, cutting. We're going to talk about these in detail. Number one, the weldment, right? So you're going to hear a lot of things talk about the weldment itself. So in this case, this is a different weld. This is one piece, but this is a different weld than this is, especially in this position, okay? This can even be a different weld than this. Naturally, it's a different joint. But what if this is from this standpoint here, it's in an uphill progression. I can see it ends at the top there, okay? But in this one right here, they started at the top. I can evaluate from the weld. I can see the ripples are going a different way versus this one, the ripples are going in this direction. So this was done with an uphill progression. This was done with a downhill progression, okay? These are the types of things that we want to be looking at as an inspector. It's going to help them tell us whether it was done in the correct pattern, whether it was done with the correct procedure, and everything else. Very important. I can't tell you how many welders I've seen on an API B30, ASME B31.1 or B31.3 pressure piping situations where it's supposed to be an uphill root, and they'll come in and put a downhill root in them. That's a fail. It's an immediate fail. Okay, it does not follow the procedure. I've seen them get to do two parts of the pipe in an uphill manner. They think they got me tricked. They'll come back in and try to put the hard piece in a downhill fashion. Doesn't happen, they failed immediately. We've had to cut pieces out on very expensive projects because it didn't follow the procedure. It's no longer insurable if you do not follow the procedure, okay? That's an important part of this whole situation. Common features of welding processes: the source of energy, source of shielding, filler metal, so forth. We're going to start out with SMAW, commonly referred to as stick welding. Okay, we do have an electrode, a stick electrode that we use in there. But the technical terminology for it is the shielded metal arc welding. Naturally, we know it's an arc welding process. We can go from there.